This is the notes for section 3.5, proving that lines are parallel. What we need to know first is that when we have corresponding angles are congruent, then the lines are parallel. Alternate interior angles are congruent, then the lines are parallel. Alternate exterior angles are congruent, then the lines are parallel. Consecutive interior is the only one that's special over here. And this has to equal 180. Because that's what supplementary means, is that they have to equal 180. Once we know that they're equal to 180, then we know that the lines are also parallel. Two lines are perpendicular to the same line. So we call this the perpendicular transversal theorem. And to be really honest, they're all theorems. They all state this as a theorem. And we could also talk about its converse or the reverse order of these statements. We're just going to focus them by name as their theorem. What does this one mean? What this one means is that if you know that this line is perpendicular and this line is perpendicular, that the two lines are now parallel. So if the transversal, being this one right here, cuts at two perpendicular lines, then they're parallel. Well, it makes sense, right? Because these are 290 and they're corresponding, so the angles would be congruent. All right, we're looking at this picture right here. We have 1 and 5. What kind of angles are 1 and 5? Corresponding. Very good. Corresponding. Because they're saying that corresponding angles are equal, now we can say that line A is parallel to line B. Now we got angle 4 and angle 6. What kind of angles are those? Alternate, exterior angles. And this is a theorem that says that the alternate exterior angles are congruent. That's why we can say that line A is parallel to line B. 2 and 8. What kind of angles are 2 and 8?
Alternate interior angle.
Very good. Alternate interior angles. And because those two are congruent, now we know that line A is parallel to line B. Two and five. What kind of angles are 2 and 5?
Consecutive.
Very good. Consecutive. Interior angles. And it's a theorem, like I mentioned before, but telling us that they're equal to 180 is telling us it's supplementary. And that's enough to say that line A is parallel to line B. Angle 2 and angle 4, what kind of angles are those?
Perpendicular.
Those are vertical angles. Let's go back to our list. Is vertical angles anywhere on here? No. So because they're not on there, we know that this tells us nothing. It's not enough to prove anything that vertical angles are congruent. All right, so now it's telling me that A and C are perpendicular. A and C are perpendicular. And B and C are perpendicular. And this is by the perpendicular transversal there. That now we can say that the line A is parallel to the line B. All right, if we move inside. We always start with the given. We have that angle 3 and angle 8 are supplementary. Three and 8. What kind of angles are those? Those are consecutive. Very good. Consecutive interior angles. And that's enough to tell me that line A is parallel to line B. So I haven't been writing line, but your answer should always have line. And the name of the line is always a lowercase letter. So please don't change it to a capital letter. That means a point of intersection. Okay, next. What do we always start with? The given. And it says that angle DEG and angle GEF are complementary. That means that this angle plus this angle are both together 90 degrees. The other piece of information is that the segment DE is perpendicular to the segment DG. And what that means is that this is also 90 because this and this are at 90 degrees perpendicular. Now we can say that the measurement of angle DEG plus the measurement of angle GEF equal 90 degrees. And that's because of the definition of complementary. The other thing that we can say is that the measurement of angle EDG is equal to 90. And that's this one right here. And this one is by definition of perpendicular. Okay, so what we have so far is that this one's equal to 90 and this one's equal to 90. So I'm going to draw the lines this way. And I have 90 and 90 right here. That's enough to say that consecutive and I'm sorry, I put another T on there. Consecutive interior angles are supplementary. That's what that theorem states, that they have to be supplementary. They're not equal to each other. and giving us that the segment DG is parallel to the segment EF. What do we always start with? The given. And the given says that angle 1 is congruent to angle 2, and angle 1 is congruent to angle 4. Without having to write anything else, I'm going to rewrite angle 2 is congruent to angle 1. What's the reason that I want to do that? And angle 1 is congruent to angle 4. So I just rewrote it. Remember, the symmetric property is the one that flips these around. And now you have these two things. Why would I want to write that? Now I have that the angle 2 is congruent to angle 4 by the transitive property. So we'll take a look. This is 2, and this is 4. And they're equal to each other. And if I draw the lines parallel like this, they look like they are consecutive interior angles. Oh no, alternate interior, alternate. And yes, because the alternate interior angles are congruent, they're equal to each other, now we can say that the segment DE is parallel to the segment GF. And our last one. We have that the angle 1 is congruent to angle 9. Angle 1 is congruent to angle 9. What kind of angles are those?
The consecutive exterior.
They're corresponding. And because they're corresponding, that bit of information is enough to tell us that line C is parallel to line D. And the other bit of information that they give us is that angle 9 is congruent to angle 15. And this information was given. So angle 9 and 15 are what kind of angles? Alternate.
Exterior.
Very good. Exterior angles. And that's enough to say that A and B are parallel. A is parallel to B.